Welcome to the Project Finance course. In this course, we want to learn how a decision is made to fund a project. The reason this is important, of course, is that if we know investors and lenders' motivations, we can create a financing proposal that will be accepted and increase the chance of actually starting our project. Because remember, a project plan without the necessary funding is no more than a wish. Unfortunately, money is scarce. The people who have money, such as banks and investment companies, have more calls on their money than they have money to invest. They cannot satisfy everyone who submits an investment proposal. They need to make choices about which proposals to back and which ones to reject. These investment proposals could be quite diverse in nature, ranging from opening a new store, building coastal defences, to cleaning plastic waste from the world's oceans, for example. In order to choose wisely, investors need a system that can compare these proposals like for like, and that can apply an objective criterion to weigh them one against the other. There is exactly such a system, and it's called financial analysis, and it is what investors and lenders will apply. And it makes use of the fact that all proposals require cash flows to invest and to generate cash inflows when they start to operate. These cash flows give a uniform objective and a measurable criterion that applies to all investment proposals. A power plant will produce electricity revenues, a new store or website will generate product sales, and an education will generate higher earning potential, for example. Then, when we have them, we need to value these cash flows, to compare them like for like. You could simply add them all up and go for the proposal that creates the highest value per invested dollar. Let's look at two projects and compare their cash flows. Project A and B both require an identical investment, which is €1,000. And after 5 years, they've both generated an identical cumulative cash flow, which is plus 350. However, there is an extra step that we need to take now. In valuing the cash flows, we need to take into consideration their timing. Later cash flows are worth less than earlier ones. If we have a choice between $100 today or $100 in a year's time, we would not be indifferent. With $100 today, we could have 104 after 1 year if we put the money in a bank account at an interest of 4%. We call this concept the time value of money, and we do this by discounting the cash flow at the prevailing interest rate, the so-called discount rate. The analysis we apply here is called discounted cash flow analysis, or DCF for short. The formula we apply is as follows. C is a cash flow, and we divide that by 1 plus I to the power n, where I is the prevailing interest rate and n is the number of periods that we have to wait before the cash flow comes in. In this formula, the present value is lower if the divider is higher. The divider will be higher if the interest rate is higher and if the period that we need to wait, the n, is longer. Then we can add all these discounted cash flows up to get the net present value of our investment, or its NPV. A higher NPV suggests a more attractive investment. Now let's look at our two projects again, and let's factor in the time value of money. We're assuming that the discount rate is quite high for illustrative purposes. We divide each cash flow according to the formula and get the net present value of each cash flow. We add them up to get the NPV. Now we see that Project A is clearly more attractive because its cash inflows came in earlier. The NPV is the first criterion that investors and lenders will apply to determine if an investment is attractive. If an investment has a negative NPV, it will cost more than it generates, and in an economic sense, such an investment would only destroy value. Let's go one step further now. Now we want to determine what rate of return an investment is expected to generate, because a higher return is generally more attractive than a lower one. The second criterion that investors will apply is the internal rate of return, or the IRR. We can use the same formula to calculate this, but now, instead of applying a given discount rate, the I, we ask what rate will make the NPV 0. This is an iterative calculation in which we seek the right discount rate. We'll see that Excel provides a useful formula for this. Let's look at the two projects again. Project A has an NPV of 0 if the cash flows are discounted at a rate of 12.08%. Therefore, Project A has an IRR of 12.08%. Project B's IRR is 9.94%. That shows again that Project A is the more attractive of the two, and it quantifies by how much. Now there is one last step that we need to take. We need to determine the investor's hurdle rate. That is the lowest level of IRR rate that is acceptable for the investor. It's a hurdle that we need to jump over to get his investment. We need to understand that an investor needs to raise funding himself. The funding he provides to you also costs him money. He needs to make a return from your investment that is at least equal to his own funding cost, otherwise he would be down on the deal. We can conclude that our project IRR needs to be above the investor's hurdle rate. Summarizing these three criteria. A potential investor will want to break an investment proposal down into expected cash flows. Then, allowing for the passing of time and the interest cost of waiting, the investor will apply a discounted cash flow analysis. In this analysis, he'll apply three criteria: the net present value, the sum of all cash flows valued today, the internal rate of return. This is the effective rate of return that the investment can be expected to generate. And that IRR then needs to be more than the investor's hurdle rate to be attractive. A few remarks on the IRR and on what return is enough to attract investors' money. Here we need to realize that there is a direct relation with the investment risk. The lower the risk, the lower the expected return. If we are lending to a strong government, the risk is low, and investors may be happy with a return of only 1%. The higher the risk, the higher the expected return. If we are investing in a startup company that has yet to prove itself, the investment risk is probably much higher. An investor may require a return of 15% then, to compensate for taking his higher risk. When we begin to talk about the project risk management further on in the course, we'll see that there is a lot that we can do to reduce the project risks, and if we do so, we can reduce the project funding costs as well. With knowledge of these criteria, we can appreciate that one of the first things we should do in the early stages of developing a project is to analyze the expected cash flows. In practice, that is often referred to as building the business case. If the potential returns are hopelessly low, we cannot hope to attract project funding from private sector investors, and all the costs and work that we spend on developing this project may be in vain. Often an investment proposal has significant social, environmental, or other benefits on top of or instead of the cash flows. These usually flow to everybody, not only to the investor. Everybody enjoys cleaner air, fewer traffic jams or less CO2 emissions, and everybody enjoys better coastal defences. The financial analysis system that we have described here provides that these are generally only of a secondary importance for the private sector investors. They tend to look primarily at the return that they can expect themselves, not so much as the benefits that flow to everybody. They may think, why should I invest in a road if everybody else can use it for free? That is one of the reasons why we need governments to organise such collective matters for us.